In this presentation, we will see the difference between an array and a single linked list in terms of representation. So let's get started. We want to store a list of numbers. This is the list available in front of us, that is 23, 54, 78 and 90. Our job is to store this list in a memory. For this purpose, there are basically two ways available with us. Or we can say that there are two data structures which we can actually use to store this list. The first data structure is an array data structure and the second data structure is a linked list data structure. We can use these two data structures to store this list. Let's see how to store this list in an array data structure. This is how a list looks like in an array. First element of this list is 23, second element is 54, third element is 78 and last element is 90. I'm assuming the base address of this array is 1000 or the address of the first block of this array is 1000. And I'm also assuming that the size of integer is 4 bytes. This assumption is important because this gives the address of the second block of the array and so on. The address of the second block of this array will be 1004, the address of the third block of this array will be 1008 and the address of the last block of this array is 1012. In an array, elements are stored in consecutive memory locations, isn't that so? Here you can see the elements are stored in consecutive memory locations because the memory blocks are allocated in consecutive fashion. Here the first block address is 1000, second block address is 1004 and so on. The elements are stored in consecutive memory locations and that is why we can say that array is the sequential representation of list. Now let's see how to represent a list in linked list. This is how a linked list looks like. We have already seen how a single linked list looks like, right? This is a single linked list because the navigation is forward only. We can go in forward direction, but we cannot go in backward direction. It is not possible to go from the end node to the first node, but we can go from the first node to the end node. This is the list we want to store and this is how we are storing it. The first node contains this particular data, that is 23, second node contains 54, third node contains 78 and last node contains 90. You can see the addresses of these nodes as well. This is 1000, this is 5000, this is 4750 and this is 3978. I'm assuming these addresses, of course. This is not something that I have taken from somewhere. This is my assumption. This assumption is important because these nodes are not representing the consecutive memory locations. Right? You can see the addresses are different. They are not consecutively stored. They are randomly stored in the memory locations. You can see there is a pointer, head, which is the pointer to the first node of the list. Obviously, this is my assumption. You can name it according to you. This is a single linked list representation. Here you can see the nodes are scattered here and there in the memory locations, but they are still connected with each other. Isn't that so? You can see over here that the link part of each node contains the address of the next node. The first node contains the address of the second node contains the address of the third node and so on. The nodes are scattered here and there in the memory, but they are still connected with each other because of the link part of the node. And this is what we should remember about the linked lists. So from this representation, it is clear that linked list is the linked representation of list and it is not a sequential representation of list. Here the nodes are scattered here and there in the memory, but they are still connected with each other using the link part of the nodes. And that is why it is known as linked representation of list. Okay friends, this is it for now. Thank you for watching this presentation.